So in this video we'll be modeling this top yoke using surface modeling, and this is loosely inspired by the Kawasaki ZX4RR top yoke. So I'm going to break down this top yoke into 5 shapes to help simplify and visualize the way to model it. Starting with the fork clamp. The fork is going to be 50 millimeters in diameter, and I want a minimum of 5 millimeters thickness of material around that. Considering the manufacturing method, this is going to be a casting, so I'm going to have a split line around the middle, which will be the widest point, so I'm actually going to increase the diameter there to 62 millimeters. So here I'm just tracing out the shape of the profile, and I'm adding some extra lines, which we call construction lines, which will be used to help constrain the shape. Now it's best practice to fully constrain any sketches, often in 3D CAD. Sketches do like to flip around and lose references at times. So now I have the complete profile and I have it fully constrained. This is just a reference for the fork diameter, which I'll change to construction line. And in a moment I'm going to be extruding this as a surface, and I'm going to need to select the whole outer profile. Because I have this circle, the circle forms a loop in itself, so to have a constant chain including the top part of this clamp is not going to be possible with the top part of the circle, so I'm going to have to use the trim tool to trim away this top part of the circle here. So we'll just use these scissors to trim these 2 lines here, leaving the outer profile to extrude. Now in this case I want a 20 millimeter thick clamp, but I'm actually going to extend it in the opposite direction to go beyond the XY plane, and that's because it's generally best practice to overbuild surfaces in surface modeling, because you'll never know when you're going to need to cut back material or extend material, so it's always better to have it overbuilt. So since it's a simple profile, we can just use the patch feature to fill in the top, and then we can stitch that together with a side surface to make what we call in other programs a quilt, a single quilt. Onto the second part, this is going to be our stem seat. So the stem is going to be roughly 30 millimeters. So I'm going to need something like 40 millimeters for the nut on the top. So I'm going to put some extra material again around the outer perimeter. Now I'm going to extrude this up to a higher surface than the fork clamp. I'm going to extrude it to 25 millimeter, and then in the opposite direction again an extra 10 millimeters. And again, same as before, we can patch the top and then stitch that to the side profile. Now we're on to the third part, which I'm going to call the simple rib. This is just joining these 2 parts along the lower edge. I'm going to make that with just using a simple sketch on the XY plane. And we could do a straight edge like this, but I think I'm going to put some curvature in here. So delete that, put a straight line, hold click to put a curve line, and then a straight line again, and then I'm just going to pull that around to get the shape that I want. So once we've got the shape that we want, I need to make sure that it's all fully constrained. Once it's fully constrained, I'm actually going to create the second part of this, which is going to be by an offset. Now you can fill in the ends with a straight line. These ends are going to be chopped away in the end, so it's really just to help us make one extrusion. I'm going to extrude it to just below the top of the fork clamps, and that's because we're going to have some rounds to bring these two parts together. And then need to extrude it down in the opposite direction, same as the other two parts, to an extra 10 millimeters. Then we can use the fill feature again just to fill in the top, but we won't fill in the bottom. So that's going to be it for the third part for now. We're going to move on to the fourth part, which is going to have a profile around the top and the inner part here with a sweep feature. And this is going to be on a sloped surface. So I'm just going to do a sketch on this plane, do a straight line, and then put in a curve, tangent, making sure that the line after that is straight and also tangent. Once I've defined the shape of this curve, there's only one more thing that I really need to care about, and that's going to be the distance between this point and the top of the fork clamp. So I'm just going to make this construction geometry reference that and make it the 3 millimeters. Actually change that to 2 millimeters. So now is to extrude this surface all the way through. Again, we want to overbuild, so it doesn't matter whether it goes too far, and we'll do it the same in the opposite direction. So once we're here, we can start working on the sketches to extrude our surfaces, which are going to be the currently the top of this model, and then the edge which our sweep is going to be coming off of. And again, it's important to fully constrain all of our sketches. So now we can extrude this top curve here, and that's going to be the surface that we're going to trim the top and then eventually merge in. We'll just extrude it at the top and then extrude it down the extra 10 millimeters as well. Now you see when you extrude the other surface, it's coming in with the colors in the same direction, but if this was the external surface, this would be wrong, and we'd want to reverse the normal. This yellow kind of indicates that it's an internal surface, and we want to keep it consistent in our models. So here, if we use the reverse normal here, this is essentially what you'll have to do. So I'm just going to undo that here. Okay, now if we select that surface and then we select it as our tool for trimming, and then we select this surface here to cut away, and then we do the same for the remaining quilt here on the top. We'll select this as our tool, we select this part to remove, we say OK. Now we can do the same for the surface that we'll be cutting our sweep line. Now we don't need the surface for now, so we can hide that off. And this is the surface we've ended up with, and I actually want to change this because I think the profile is a little bit too wide. I also don't like how this round comes on this straight edge. I'd rather the curved surface be more in line with the round. Okay, so now I want to put a plane on the outer edge. I'm just going to move it to this point here, and that's just so that I can draw a sketch on the curve. And that's going to enable us to sweep that sketch or that line right around the curve. We can change this from being perpendicular to parallel, and that'll give us a slightly different geometry. And in this way it's got this kind of pinched geometry here, which is not nice. Just bring in the rest of the geometry and just see how it comes together. So I'm going to create a sketch to trim the inner surface. I'm going to do that with an offset from the top curve. So once you have something that we like, we just extrude it up and then extrude down the extra 10mm, overbuilding the surface, and then we can start trimming it into the existing quilt. But before that, I need to extend the edge to come beyond the mid-plane, and then we use the mid-plane to trim it back. And then we still have the normal surface being incorrect here, so we have to reverse normal so that it's the external surface. And then we can start trimming the surfaces and stitching them into a single quilt. Okay, and now for the stitch. And once this is stitched together, it's going to be much easier to trim it with other groups of surfaces, other quilts. And we'll start with trimming with the stem seat and removing that bottom surface that we had remaining, and then the inner surface as well. Then we'll start trimming off the ends of the other quilts that we've made already. And then we'll also use these rib-like features to trim away sections of the fork clamp and the stem seat itself. And since we are mirroring this part, we can use the mid-plane and cut away the other half of the stem seat. So now I'm just looking to see how I'm going to build in the ignition barrel. I'm going to start with sketching out the outer perimeter of this ignition mount, and then I'm going to extend the existing surface through that mount, and then we'll use the perimeter surfaces to trim that away, and then eventually fill it and trim it into the existing body. Unfortunately, I've lost some of the recording, but as I said, it was just extending the original surface out and then trimming it with the perimeter and then trimming it down and then eventually stitching it in. Now I actually want to put a little bit of an extra kind of interesting geometry into the surface here, so I'm just going to build a kind of bowl kind of shape that's going to merge into this top surface. Once you've got the initial shape, we can start sketching in and extruding in the side. So once we've sketched that out, we can extrude it up, put some taper on the extrusion, and then we can start looking at trimming it into the original surface, adding in some rounds between the two surfaces, making sure to stitch them together first. And then we can start trimming it into the existing quilt for the yoke and then merge it together before adding in some more rounds just to tidy it up. Okay, so now we have the complete left side of the yoke. We can mirror it about the center plane to create a full body. We're still missing the underside. Now I actually want to create the bottom surface. I'm going to do that by extruding a straight surface across the bottom of this part, and then we'll merge that into the existing profile. Now that we have that complete again, we can re-mirror the part across since the quilt's changed, and then it will be stitched together automatically as a solid body. Okay, so we're almost there now. We've got the core shape of the top yoke. Now we need to start focusing on some manufacturing details, such as the split line for the casting. So I'm going to make this with an offset from the bottom of the surface, 10 millimeters into the body, and then we're going to create a draft around the whole part and on the internal surfaces as well. Having said that, there are going to be some holes in the fork clamps and the ignition barrel and the stem seat, which are going to be made from the casting process, undersized holes which will then be machined out. So I need to make those holes now, and then we'll include those in the draft feature when we make them in a moment. As I said, these holes are going to be undersized because we're going to machine them out later. Then for the stem seat, lastly for the ignition barrel. So you can see when we do this cut, I haven't cut all the way through, which I would like to fix. Cut all the way through the material. Now we're ready to create a split line around the whole part. Also for the internal surfaces for the fork, stem and ignition barrel. So for this we're going to use the draft feature. Just going to select all of the outer surfaces, followed by all the internal surfaces. Select the pull direction. Select splitting surfaces. Finish selecting all the external surfaces and then go on to the internal surfaces. Then we can change to that draft to be symmetric about our split line and then put in our angle. Now whenever you're doing a model like this, we may have a different plane for our casting, so we can always come into the draft analysis in the utilities section and then select a draft analysis, selecting the direction in which our angle should be relative to. So in this case I'm going to select the body and then select the direction as the top surface, and then we'll leave the draft at 2 degrees, and we'll see quite clearly where the split line is on this part and if it's acceptable or not. So we're ready to start adding in some extra details. So before we put in the rounds and chamfers, for example, we've got one more model part, which is the ignition mount. So we have the hole where the barrel will sit, but we need to have the mountings. So I'm going to extrude some surfaces from this offset back into the part with a taper equal to that draft angle that we've just applied. Okay, so now the core of this part is complete, we can start looking at the rounds and chamfers and stuff that we're going to add. In addition to that, we can consider some weight reduction, so we'll remove some material from this section here. And that's going to be as part of a cast feature. After that, we need to start adding in the machine features, like these fork clamps and these stem seat holes. So there are some other features I need to add, like here we need to put a stop for the clip-on handlebars, where the handlebar is going to lock into the top yoke so it doesn't rotate. Then we'll have a chunk of material removed from here. We need to put in some pinch bolts. And then there's just the general rounding and chamfers to tidy this whole part up and bring it together. So whilst I take my time on this part, I thought I'd just take the time to talk a little bit about experience in industry with surface modeling and why it's more common than solid modeling in many areas. Often, if we're working with data that we've received from third-party suppliers or OEMs, this data is going to be in a format that we can't really work with in solid modeling. We'll be referencing the external geometry, maybe we'll be using the external surfaces, maybe we'll be merging those surfaces into our parts, or perhaps we've received some surface data which we need to incorporate into our models, and that may be from the industrial design team or perhaps a contractor that we're working with. The surface data that we get is generally much better quality than what we'll produce from any simple sweeps or lofts that we might produce. And the sweeps in this model, for example, are really not good. We can see how it is pinching when we had it in perpendicular, and then we change it to parallel, and the direction of the curvature is just all wrong. If it was to be reviewed by the design team, the industrial design team, they would probably not be happy with it, and they would send us better quality surfaces for us to then build into our model. So it's very important to learn how to work with surfaces, to merge new surfaces into our existing quilts, not having to start the whole model again because it may take a lot of time. Whilst it may be easy for us to just draw and create a random top yoke like this, or take an existing yoke and model it out ourselves, it really can't be overlooked the amount of knowledge and experience the manufacturers actually have of the manufacture of these parts. Not just the manufacture, but the design for manufacturing. They're likely to have lots of documentation and guidelines that they've built up over time of how to best design most of these components, ensuring the rigidity, the quality of surface finish, the ease of manufacturing, optimal weight reduction. All of the aspects of the design of these components, they will all have been documented throughout the years of experience. So many projects. It's not just one project per year, there's multiple bikes going on each year. All this data is being collected. So whilst my core experience isn't in cast parts like a top yoke, for example, I did have some experience working on hangers, rear hangers, and foot pegs and things like that. But my core experience is in frames and frame design. And the structure analysis as well, so constraining the motorcycle in various locations and then applying loads at the footrests, the rear hangers, on the seat itself, as well as considering the mass of the tank that's going to be bolted to the frame and how that's going to affect the frame under hard stopping conditions. As I progress through these exercises in building these models, I will probably venture into seeing what Fusion 360 can do in the way of structure analysis. So you can look forward to content on this in the future. Okay, so if anyone has any requests for components that you'd like to see me model or see how they can be built, please feel free to leave those requests in the comment section down below. If you have any requests regarding anything for the time being, please leave them down below. I've actually left a lot of more material than I need to here, so I think in the future if I was to remodel this I would definitely thin it down. I'm just going to sketch out the geometry that we're going to use to revolve a cut around the stem seat area, so I'm just going to put that in now relative to the axis of the hull. Then we'll do a revolve cut to cut this out. I think it would actually be best practice to model each and every one of those cuts, because in the future you may do a drawing where you show it in stages, and in this case we can only hide them all in one feature. Now I'm just adding in the anti-rotation stop for the handlebars. I'm going to add the sketch in first and mirror it across, and then we'll use the hole feature to make those drilled hole features. Now do the same thing for the ignition barrel mounts, a couple of sketches, and then we'll add in the hole feature. As for the fork clamps, you've got a bit of extra geometry to cut out here. You need a 2.5mm cut through this piece of material, so just going to make a box symmetrical to this line, which is perpendicular to the front edge of this clamp, and then we're going to extrude that and cut it through the clamp itself. Then I'm just going to machine away the inner diameter of this fork clamp to the 50mm required. Then I'm going to make an offset from that previously cut surface to a depth into the body where the bolt head is going to be seated. Make sure that this cut is going to have enough space, a big enough diameter for the bolt head to seat and clamp on. Then we'll do another sketch on that surface, a smaller sketch, and then we'll use the hole feature to drill that hole into the body of the part. Now with that complete, we can select all of these features, and then we use the mirror function to mirror it across to the other side. Now we have all those machining features complete. We can start adding in the rounds and chamfers to finish off the shape of this part. Just missed the machining process for the ignition barrel, so we just machine that out now. And in actuality, when you machine these faces like this, we're likely to have a very small chamfer at the bottom. So we can model those in as well, just say 0.25 millimeters or something like that. And then with all these kind of parts, we could have potentially sharp edges. So we tend to remove any burrs that may be remaining. And that may leave a very slight round or chamfer. So we can apply very small rounds and chamfers as we finish off this model. Usually we'd have all of the machining features come in at the end, and we'd have that so that we can suppress them all for multiple different levels of drawing. We could have a cast drawing, and then we'd have a final drawing, which includes the processing. Now we've applied all these rounds and chamfers, it's just going to be another double check that we haven't messed anything up and the draft is still looking to be acceptable. Now we can apply materials in 3D CAD, but we can also apply appearances. In this case we can go to the render mode and we can start applying appearances. From this collection, this library, we can download parts that are pre-created and apply them either to the component or to specific faces. So in this case I'm going to select the cast steel and I'm going to drop that to the entire body, and then I'm going to use the polish steel on all of the machined surfaces. I'm going to first select faces and then select the individual faces that I want to change to polished. Just undo that and then try again. You can actually select multiple surfaces and then apply the appearance that you want. I believe it's holding shift click as you select the surfaces, and then you drop the surface onto any of the ones that you've selected and then it will apply to all of them. Okay, so once that's finished, we can then start rendering the image, either as like an image like a PNG, or we can even make some short videos where it's like a turntable. And of course, do not forget to save your progress. 3D CAD does crash very often and nearly always at the worst possible time, losing you so much progress. So this has been my second exercise in modeling a top yoke. This is a kind of simple surface model. I'll move on to something more complex on the next one.